All right, in 4.4b, we're just going to continue on with more examples of solving exponential and logarithmic equations. Picking up with example 17. A to the 3x power equals 360. So what I would do is rewrite this as a logarithm. So 3x equals the log base 8 of 360. All right, and then to get x by itself, I'm going to have to divide both sides by 3. All right, so use your calculator. So we'll go to math, go down to A, log base 8 of 360, and then divide it by 3 to get 0.944. 18. Very similarly, I'm going to move my power out and write it as write it in logarithmic form. So it's negative t over 2 equals the log base 5 of 0.20. Now to get t by itself, I'm going to multiply by negative 2 on both sides. So this is going to be negative 2 times the log base 5 of 0.20. Right? That negative 2 will make this just t equals whatever I get here in my negative 2. I get a nice even 2. There it is. All right, on 19, we have an extra step here. We need to get rid of this 250 first. So I'm going to divide both sides by 250. So I'm going to isolate the exponent in its base, basically. So 10,000 divided by 250 is 40. Now to rewrite this as a logarithm, it's going to be 0.02x equals, since it's an e, I'm going to do the natural log of 40. Divide both sides by 0.02. So x is going to be whatever my calculator gives me. The natural log of 40 divided by 0.02. And I get 184.444. All right, and on 20, we got a lot of steps going on. We want to isolate this guy right here, but we need to peel away the layers first. So I'm going to first add 13 to both sides. So I have 5 times 2 to the 3 minus x power equals 113. Now I still need to get rid of the 5, so I'm going to divide by 5. So now I have 2 to the 3 minus x power equals 113 over 5. Now I can rewrite this as a logarithm. 3 minus x equals the log base 2 of 113 over 5. Then I'm going to free from both sides. So negative x equals the log base 2 of 113 over 5 minus 3. So all of this is kind of isolated. And then I need to get rid of the negative. So multiply both sides by negative 1. So I'll have x equals negative log base 2 of 113 over 5 minus 3. And if I put this in my calculator, running out of room and time, so it's going to come out to negative 1.498. All right, but you just follow your algebraic steps to get there. All right, look at 21. So hopefully you remember our properties of logarithms and exponentials. If the bases match, the bases go away and everything drops down. So x equals x squared minus 2. Now the way to solve this is to get everything to one side, get it equal to 0. So I'm going to subtract x from both sides. So I have 0 equals x squared minus x minus 2. And then I can factor this. This will be x minus 2 times x plus 1 equals 0. So I can solve this, that x will be 2 and x will be negative 1. So there's two solutions there. Let's look at 22. very similar. Bases are the same, so exponents drop down. And let's consolidate, get everything over to one side of our equation, leaving x squared positive. So x squared minus 4x plus 2 equals 0. Well, that does not factor. So I'm going to use quadratic formula. So it's going to be 4 plus or minus b squared, which is going to be 16 minus 4 times a times c over 2a. Well, that gives me 4 plus or minus square root of, that's 8. So square root of 8 over 2. So I continue to reduce. I have 4 plus or minus 2 square roots of 2 over 2. Well, I can divide each component by 2. That leaves me with 2 plus or minus the square root of 2. All right? So my answers then are 2 plus the square root of 2 and 2 minus the square root of 2. All right, so x has 2 solutions on that. All right, 23. Pretty straightforward. All I have to do is swirl this. So e to the negative 3 equals x. I can put that in my calculator, and I find out that x is equal to 0.050, straight from the calculator. Now in 24, it looks really complicated, but in reality it's pretty simple, because you remember our property, the log base, if they match, they go away. So really I just have 3x plus 2 equals negative x. All right, so I'm going to move my x over to the left. So I have 4x plus 2 equals 0. 4x equals negative 2. Divide by 4. So x is equal to negative 1/2. Using those properties of logarithms, it becomes pretty simple. All right, look at 25. Again, using the properties of logarithms can make this really simple. Now, the issue here is I have 2 natural logs on the right and only 1 on the left. I need to get it down to 1. So using the product rule, I can do that. I can say the natural log of x plus 5 equals the natural log of x minus 1 times x plus 1. All right? Now, this is being multiplied together here. Now, my natural logs, I have 1 on each side, same base, so they cancel out. So then I have x plus 5 equals, I'm going to go ahead and FOIL this out, and hopefully you recognize this is going to be x squared minus 1. Then I move everything over to the right, so it's equal to 0. X squared minus x minus 6. This will factor, so I have x minus 3 times x plus 2. So x is equal to 3 and negative 2. Now, don't be too quick here. You need to check your answers and make sure it's valid. Can I use a negative 2 here? All right. So would a 3 work? Well, when I put it back in the equation, 3 plus 5 is 8. That works fine. 3 minus 1 is 2, so that's positive. That's good. 3 plus 1 is 4. So that works. Now, if I go back and check my negative 2, what's going to happen? Negative 2 plus 5 gives me 3, so it works. As long as this remains positive, it's good. Negative 2 minus 1 is negative 3, so I can't take the natural log of a negative 3. Therefore, negative 2 is not a valid answer. So really, the only correct answer is 3. So let's look at 26. Again, 2 logarithms. Let's see if we can consolidate these down. So using our properties of logarithms, we're going to use the quotient rule because it's a minus sign here. Okay. So I have the log base 4 of x over x minus 1 equals 1/2. Now, if I swirl this, so I'm saying 4 to the 1/2 is equal to x over x minus 1. Well, remember, our 1/2 power is square root, so it's going to be 2 over 1 is equal to x minus, or x over x minus 1. Cross multiply, x equals 2x minus 2. Let's clean this up. Subtract my x, 0 is x minus 2, so x equals 2. Okay. So let's look at 27. So we ultimately need to get this logarithm down to by itself. So let's kind of peel the layers. So it's going to add 2 to both sides. So 2 natural logs of 3 is equal to 19. Now divide by 2. So now I have the natural log of 3x is equal to 19 halves. Now to get the x out of the logarithm, I need to swirl this. What's my base? It's e. So it's e to the 19 halves equals 3x. All right, so now I'm going to divide both sides by 3. And I can plug this into my calculator. E to the 19 halves. It's crazy, but it works. So let's see. E to the 19 halves divided by 3. Big old number, 4453.243. 4453.243. Okay. A couple more. All right. Again, got to peel away the layers to get to the logarithm. So the first thing I want to do on this one is divide by 7. Okay. Then I would swirl this out. So it's 4 to the 12/7 power equals 0.6x. Divide both sides by 0.6. And x is going to equal 4 to the 17.9. All right, last example. Now, how can we move this? Well, remember our power rule. You can take that 2 and move it to the front of the logarithm, and everything remains good to go. Then I would just divide both sides by 2. So it's the natural log of x plus 1 equals 1. Then if I swirl this, keeping this intact, e to the first is x plus 1. Subtract 1. E minus 1 is equal to x. I can put that in my calculator. 1.718. All right, I hope that makes some sense, gives you some more examples to work with. We'll see you in class.